and use quad here, then use quad here. So don't mind the formulas I'm writing. If you're not comfortable with LaTeX. Okay. Yeah. The focus is on understanding what is the pipeline. So you apply many functions on the data X. So X is the data actually. So X passes through F, and then passes through J, passes through H, and so and so. Okay. But when it passes through F, the end result will be F of X. So F of X is taken to J, and so and so. So let me illustrate this by an example. So last time, what is the data we loaded? I think climate, right? Yeah. So let me locate where the data is. So I have my folder data. Yeah. So we started with climate row, right? So if you remember the dir here, dir means show me everything that is in the folder data. Okay. So I'm going to let's import the climate data. So I'm going to call it climate row is equal to read. It's a CSV file, so read CSV. So it's in the data folder, and from the data folder I can take now this. Okay. So what do we do to check the structure of the data? If you remember, I know we can str. It's not string. Str means structure, but in Python it means string. Yeah, str of climate. So this gives you the structure. As you can see, many variables, even the age, which is supposed to be numeric, is character. This is a problem with the data. It's a huge problem. Okay. Where else? You see, admission dates. Normally they should be dates, but they're shown as character type. Okay. Even treatment cost. Normally it's a cost. Should be a numeric. If you want to like do the histogram of this variable, should be numeric. So we are going now to clean the data. We are going to do some cleaning so that we can, if you feel that there is something that is, forcing R to do the conversion into character to be able to keep the data, we are going to find out what exactly is doing that, all right, and be able to correct it. Okay. So the visit ID, I think all IDs, we don't care much about identifications unless there is something that is pulling us back later. Full names, for now, let's not care a lot about full names, but we are concerned about age, which is normally numeric variable, but it appears to be what? Character. So if you want to locate, how we dealt with with lists or data frames. If I want to now extract the variable age from climate row, how do I do that? I have the data climate row. I need to access the what? The variable age. How do I do? You forgot. From the table of climate, I just want to locate age so I can have a look at it. Huh? No, we don't. I just want to extract. Yes. Yeah, if you have the answer, don't like react. Yes, we use the dollar sign to access all variables in the dataset. Thank you, Colette, and the man behind her. So yeah, here's the variable age. So I will use the pipe later, but for now we want to see exactly what is in the table. So what is forcing the variable to be character is because we have some non-numeric variables, spaces and years and so and so. So now we are going to use the tidyverse and the pipes to say, okay, if you detect any space and year in the data, remove it. Okay? We are going to detect patterns like this and then we remove them. Okay? Yeah. So how do we detect patterns? There is this function we call grep. Grep, the grep function is will return a logical variable, a logical vector. But if you just use grep, this returns also indexes. Okay? So that function, what it does is it can locate in a particular pattern somewhere in the variable. Okay? So I'm going to say grep L. Now locate where you find space and year, like this, like these ones in the data. So you can just copy and paste it here. Okay, let's do it together. And this is the pattern to detect. That function takes 3 or more, but the most important are 3. So detect years where now is in the variable we are going to provide. Okay. Okay. So now this one is going to, if for instance you have also like cases where you have capitals, y is in capital, because R is case sensitive, you can add another argument which is ignore cases. So ignore cases, if you put it, you set it into true, means that the pattern, even if it is capital Y, capital R, it is going to detect it. So it is breaking is bypassing the case sensitiveness. So now this is a vector of true or false. So if you find true, means that at that particular position, there is that pattern you are looking for. Okay? Yes. If you need evidence, then you can take the same variable and use the result as an index. Okay? So you just we turn it into index, and then you put the variable before. Now, you see, we have detected. That function means from the variable ages, detect where you find the space here, all right? And then ignore from that same variable, ignore cases. So now it is bringing all results. Okay? Yes. Okay? So this is detection. If you are able now to detect it, then you can, right? It's like you locate where terrorists are and then you can shoot. Those are terrorists. Yes.
dataset you are using, is it climate or partial?
Climate row.
Climate.
Yes. It's here.
It's partial.
Oh, sorry.
Yeah.
Anyway, we can go with patient.
Yeah.
We are going to touch on all those later. I took. Sorry. So we move to patient. Yeah. Or I can go to climate row if you want.
Partial.
Passion is okay, yeah.
Some are using climate.
Because I mentioned it, I say climate, and now the data. I didn't. I was not cautious at all. So please import the data, and then if you need any explanation about the last thing, I will see you. We want to move faster, but we don't want to move without you. And me, when I have coffee, I become like a tube. Hey, you don't speak for that. Why are you shining like this? That's why you like that. C'est un autre terme. Ça doit aller. La dernière fois que nous avons travaillé, so now, instead of calling it climate, I'm going to change the data name as patient. So
dore icyiza nturazandika dore sosiyete yawe yose ugashyiraho izina ryawe bracket ushinzwe urabona kubwira iyo imaze gutya isi yaratse n'imikara ntabwo gutya akwiye kuba ari n'amategeko y'amayikara y'umuntu ubibaza n'iki cyangwa
Okay. Have you all imported data?
Yes.
Not yet. Okay, now let's analyze. Let's do some data wrangling. So if you want to see cases, here's how we do. I'm going to introduce you to, so the first one is to three functions. When it comes to detection, this one is grepper. This one is for indexes, and this returns true and falses. Yeah. Then if have you done this? Please take time to. So I'm going to change the data name also from climate to patients row. Okay. So the below line of code means detect all entries with the pattern space YRS. Okay. And since the part in the square bracket is returning a Boolean variable, we can use it as index. Okay. Hmm? Mm-hmm. So now after getting this, what is the obvious question? There is no wrong answer. You can answer. If we can detect, what else can we do? Change. So the question is, how do we remove the unnecessary parts so that we can easily convert from what character type to numeric type. So for that, we have a new function called gsub. Okay. So the sub is for substitution. Okay. You are getting an error. Okay. Okay. We didn't run the data import. The code is fine. But you go up, run the reads, yes. Yes, you have to run as well. This one. Mm-hmm. Run again. but you got it patient, but now you use it down to as patient row, which is not defined. Well, you add also the row here. It's just patient, but you have to add patient row. Should be the same variable. Yeah. Yes. Now you run again. Now you run this one as well. Yeah. And this is not defined. You have to also patient row. This is a comment. So click on it and do control shift. This one. Steps. Yeah, control shift. Shift. And see. Control shift. See. What is the You see, arguments are already programmed there, so you don't have to struggle with it. It's what not well written. You just you start with case, just use tab. It means that the function is not in the right way. Grade L is not double F. Yeah. And then just write in like this and use tabulation. It will complete it for you when you can add the two. Yes, now run. So question is, yeah, there's no S. Good. Yeah. So I'm just trying to pull this out so that we can, we have used how many functions? One function now, right? So to delete this, we are going to use a second function, which is gsub. Then I will show you how to now pipe things. Okay. This one is to substitute what? Patterns from a string, a variable. So let me just take this one example. And so if it works on one, you know how to make it work on a vector. So if I use the gsub, as you can see, it has now pattern. So which pattern do you want to detect? And then has another argument, which is replacement. You see, replacement. And x is the variable you are operating on. And it has also the ignore case if you want to avoid case sensitiveness, okay? So let's say I want to delete everything that has space here. And the replacement, we replace by what now? If you want to get rid of the space and years like this, you replace by empty character. And then from where? From, let's say this is the variable. I'm just taking one of them. But you can put a whole vector here. It works, okay? Now, if I do this, you see now I've deleted the space here from this, okay? And I remain with what? 10, which is very simple to convert into what? As dot, if I want to convert into numeric, is as dot numeric, yeah. So how many functions did we use so far? grepl, and then substitution and as numeric. So this one, take it as f function, j and h. So remember the pipe up here. So let's say assume that there's no t function. So we send x to f, then we send everything to g, and then we send them to h. So finish this example. Yeah. And this up, even if you find the pattern or not, if you find, yes, it will remove it. If it doesn't find, it will bring the entry as it is. So you don't need to pass through even the grepper. The grepper was just illustrative to show you that, yeah, you can detect and see, but if you want to take action, you use this one alone without even going through grepper. Yes. And the danger, if you don't remove the years and blindly, excuse the term, blindly, or you just don't care, you say, let me just convert it into numeric, you see that every entry affected with this will be converted by coercion into a missing value. So we lose data. You're going to lose information if you convert directly without checking. Yeah. If you don't remove the unnecessary patterns, then all of them will be replaced by missing. So imagine you're going to miss like how many? This is 12, like 14 entries. Okay. So to do for you, replace this x, okay? I can call it even x. Replace x by this and convert the end results to numeric. So you replace this one. So if I do that way, someone is going to copy this and replace this x here. No, this is not what I mean. Okay. So x is an argument, so replace the value of x. See, if you want the value of x by this. and then you convert the result into numeric. So when I say to do, it's like we have to do, and I want to check whether we are aligning or we are together. If you face any problem, we are here. We are here to jump in. So there is, I don't know if you are able to close it up. Questions? We use the list of system. Question. What does it say? This is the form. It means something on the. Here you use this will be like this. Down in the context. So now, that is I think the energy you're having is like actual missing. There's no data. Yes. But how can someone's age be negative? What's going on here? Yeah, the person is born in the future. Yes, this is a problem. Actually, we are going to see whether we should remove the negative sign or keep it. So if there is something like date of birth, we can double check. Have you done the now you replace this 10 here by patient. This is a to do. So replace the value of x here by patients underscore row $H. So collect is all good. You complete it. Now the only problem we are facing is why do we have negative ages? So we can use another variable to solve it. Yeah, if there is maybe date of birth in the data. I've not checked all the variables, but yeah, we'll find ways to solve that. It's not a string, but remove the positions. So you all good? No, you have printed the variable. Now we are using the GSAP to delete. So this one is working for you, right? But did it work? No, it didn't. This should be a string. If you want it to be a string, you start with a quotation and end with quotation. And remember there's space. You see when you read over there is space between 10 and y. No? Between 10 and the y. 10 and the y. Between yeah, if you run this one, it's going to remove that button from yes. So now and then you convert it into numeric, which is good. But the exercise now is to replace the value of x here, the last parameter, by the variable I highlighted there, questions underscore h. If you replace, means that you are operating on the entire column. Yes, this is the exercise. You are operating on the entire column. So, we need to do like so, look between 10 and there is space. You have to look at everything. Yeah? And then let me give you a wild card. What is a wild card? It means that even if there is space or not, it is going to detect. Yes. Even if there is space or not, we have cases like that. It's not always having space. Sometimes you have 10 years. Find it. Not. So if I have something like this, you can just add a wildcard here to say, yeah, means that if you detect the space or not, this is what we call we call it what? A regular expression. Okay. This is regular expressions. You see? So if I put a space, it detects. If there is even 100 spaces, they are all removed. Because this star means at least 0 space. Yeah, at least 0 space. So even if you have like 1,000 of space after 10, it's going to remove it. Okay?
That is.
Yeah, S double backslash S means space. Okay? Now the star means at least 0 space. So if you find at least 0 space, means even if you have this case, or this, or this, or this, or this, is the same for this wildcard. Okay? But we are lucky, all you have here, space, space, space. Okay? So this, in other cases you will encounter in your data analytical or data analyst or data scientist life. All right. Now let's put everything into pipe. Let's use a pipe now to send data in functions, and you'll see how it works. Okay. So before that, let's resolve the to do. So what basically we are doing is replacing this by this. Yeah, here's our variable. So if you wonder why we have NAs, you can still detect to be sure. Why do we have NAs? Okay, I can give this one into a certain variable age numeric. Okay, if I save this one in age numeric, so I can solve the problem of why do we have. Welcome back.
Thank you.
Yes, have NAs in the results. So Tassien last time use the function to detect missing values. What is that function? I know it was 1 year ago. Yeah, what is that function? Yes, if you want to detect it is family functions. If you want to convert is as dot. Detection is dot. Is it a number? Is it a logical? Is it a boolean? Is it so is dot? Is it a data frame? And now is it an NA? Yeah, is now. Yeah. Now it returns a boolean. And as I told you, if something is returning a boolean, it can be used as an index. So you can take, no. I'm going to put the is now on this, on the result. Now I will take the original variable to check exactly why are we having isnas or NAs. So now I'm happy because anything that is returned NA was an empty character, which is a good news. Yeah, so I don't have to worry. They were missing from the, yeah, I think it is maybe an error from the, how do you call the enumerators? Maybe the enumerator wasn't able to capture it or forgot to put it, or maybe the person did not communicate about their age. So it was missing from what? How do you call it? From the data collection process. Yeah. So I think you should not worry, right? So if I say one line is not that true because we are going to break it anyway, simple to debug code. Yeah, debugging or troubleshoot. Like when you use a file, is very easy to detect errors in the code than having a bushy code like this. It's too bushy. Yes. Yes, means that. What does it mean to you? What is this? Empty string. Yeah, means that we didn't have any value. It was empty from the starting point. Yeah, it's coming from the from the age variable. It was there. Means that okay, it's data simulation. We put it there for like just for illustration sake. And later on, if you have no way to replace this one by any other variable, even if you have sometimes you may have like a date of birth that can help you to calculate the actual age of the person which is missing, like the age which is missing, right? If you don't have that mean, what do? You can replace with median or Tassian did it last time with you. Yeah? But this is a missing value. Okay? All right. Now we are going to use pipes to have simple to debug or to troubleshoot. Maybe I'm using words that are not common. Debugging is like check errors in the code and correct them. Troubleshooting is also a synonym of debugging. So we start with the X. Yeah, I'm now using the knowledge we had. So if you had followed me carefully, this is the X. I'm now going to send it somewhere in the GSUB to be able to run exactly this. Okay? So the GSUB wants the pattern. So I'm saying if you find at least 0 space, okay, followed by YRS, replace it by what? Nothing. So empty character. From where? So now, this X, we need to put it here. But how? It is already here. We need to have it here. So a simple dot can represent X. You just put a dot there. And it means that now the X is sent directly on the dot. That's magic. I'm the one who created it. Let's see. Yes. So if you run it, okay, now it is telling me that I didn't find the function. We have to import the tidyverse. So if you import tidyverse now, or the entire code is going to work for you. So another thing, when you import tidyverse, you have like a message, a lot of messages coming. You don't like them; they are unnecessary. So you just have to write warning here is equal to false, or a very simple way of doing it is just go to there is a gear here. If you check, there's a gear there. You can click on it. You can say, don't show messages, uh, don't show warnings, don't show messages. And then you finish with apply. So the code I was about to write, message is off. I don't need any message when loading a library. So off the message, and also switch off all warnings. So now if you run the whole thing, nothing is going to appear down, only your result. Now, you see, I've sent X into to F. I can send this result to another function using a pipe again. I'm at the end, Control Shift M. I have my pipe. I can now do what? What is the next function? The result is still in a character type. I want to convert it into numeric. So what is the next function? As.numeric. So if I run the whole thing, now we see. Okay. And from this even result, if I want, I can even draw a histogram. And you see, from data cleaning to visualization, directly. Yeah. So you just send the result to until the end. Yeah. And as you can see, this is just a one line of code. I'm breaking it to multiple lines, but it's just a one line. Yes. So there's someone who is born, who will be born like in 100 years, and they are already in the data. So maybe the enumerators were talking to spirits. As dot numeric means that everything after this, every process is sent in that conversion. So up to here we have like character type, and then we set it to as dot numeric to convert now the end results to numeric. So now what we are doing is outside the data. What if we want to do the changes directly on the data of patients? Now we isolated one variable, which is the variable age. We have done things on it just to see. But what if you want to do it directly in the data? So that the data gets updated whenever we add a pipe. And this is, if you are able to do it today, then you can call yourselves data scientists. This is the daily work. He's doing it right now. Eh? Blasha, I'm very sure you are doing similar things. Every day. Every day he's writing a pipe, sending data to a function, right? Custom function. That's it. And then you come up with visualization. That's the end goal. And the end goal is to be able to build a dashboard summarizing results from all your columns. You can see the relationship between columns. You can do regressions. You can do, I don't know, correlation matrices. Start. And then if you are graduating soon, maybe from your master's degree or bachelor, you can do great analytics. And the panel will be very happy with you. Okay, now we still have issues with the variable age. We don't know whether we should remove the negative signs from ages. We don't know yet, and the future will tell us. Hmm? So now I need a feedback. Are we good from here? Because the more we move forward, we add more layers of complexity. So if you are lost now, I'm sure you that you feel us already. You don't stop me. Yes, we said it will be each determined by those unnecessary things we don't. So the second, the first function is removing those patterns. It means this pattern means space. What you take space, yeah, yeah. Limit purpose. And this is what we did in several groups. We did it output and we use a lot. Using yes. You get it. So now we are going to clean the age variable using the mutate function. Okay. So you clean, where do we clean it? In patients row. So we are not going to isolate it. We are going to clean it directly in the data and save it. If you save it in with the same data name, you are just going to overwrite. Okay. But if you use another set, another name to receive the result, then we are not overwriting, but yeah, the original data will remain there, and we are going to have a new data set. We've cleaned the information. So you choose, you decide. So normally, if you run the 2 lines of code, you are not going to see simple question. Now that it is occupying a lot of places, if I just want to display the first 6, what function do I use? Head. Yeah. So I can pipe it to head if I want. Yeah. See how life is becoming easy and complicated at the same time. So I can say, let me display 20 of them, just to show the evidence. But now we are going to use the mutate function. And Tassin introduced you to it. Last time we were tired towards the end of the session. Not sure you remember how it works. And you're not serious. Missing value. Yeah. If you're wondering what exactly is a missing value, this is a missing value. There's nothing. Yeah, missing sweet. So, can we continue? Are you on track? Okay. Mm-hmm.
If I understand
Mm-hmm.
which context you can use mutate, I
Mhm.
think that we have some studies, some surveys, which we call case studies, case studies.
Mm-hmm.
And then when you want to analyze, we have to create some score.
Okay.
So we have combine, we can combine some variable
Mm-hmm.
so that we can show that we have good knowledge, moderate knowledge, bad knowledge.
Mm.
So that I think that we can use mutate,
Mm-hmm.
mutate.
Yeah. The mutate here can maybe, if you're coming from another programming framework, it could maybe mislead you. So this mutate is just helping us to add or modify. You can add a new variable in the data with the mutate function, or you modify an existing one. So adding is if you write in the mutate a variable name that does not exist in the data, it is going to add it. If you write like exactly age, it's going to transform age in the data. That's the only meaning of it. And we are going to see it now. Yes. So I'm going to start with the patient data. So now we are experts in using pipes. So I will start with the problem. Our data is raw, so it's the problem. So I'm going to pipe it into something. And that something is the mutate function. And the mutate, as I told you, you can, if I say new variable like this, and then I say everything in the new variable is missing. And then if you pipe it in the view, means that add a new variable, which is all missing, and display the data as an Excel file, like the way you see it in Excel. So if you check at the end, you see a new variable. Okay? And every entry of the variable is a missing variable here. Okay. Now, the danger with that same variable is, and that same function is like, if I say age is missing, means I'm destroying the variable age, which is already existing in the data. I'm destroying it. And then if you check what is age, I lost all information. They are overwritten. And every entry in the age variable is NA. Understand? If I use a variable name that is in the data set, I'm modifying it. I'm transforming it. If I use a new name which does not exist here, then I'm adding a new variable. Correct? Yeah. So now, let's use the age variable, but we are not going to view any data, okay? And it is not any. We are going to apply the same thing you see here, yeah?
Like patient law,
Mm-hmm.
percentage, then what is called what that one? It's pipe.
This is a pipe.
Is it not?
Yeah. So now, if you have the variable name, the data name, and then you put an equal sign like this, equal to, if you use the tab, you are going to see all variable names that exist in the data. So the struggle of having like a patient dollar is, you don't need. If you want to access a variable, you just say, I'm going to access the variable age. And I use my pipe now to redo the things that you see here until you get to that stage. Okay? And that dot will be the variable age. So if you want, you may not start with age and send it, and then you get confused with the dot. You can start from here and then put age here, and you send it into as new. Let's do it. So G sub, the pattern is double backslash small s and star, which means if you find at least 0 space followed by year, so what year as an abbreviation, yes, replace it with nothing, like empty character, and from what variable? The variable age, and it is even coming. Okay. Now I can pipe it again to dot as dot numeric to finish now the conversion. So I've modified successfully my variable age in the data. But the danger is I've not saved the result. Where do we save the result? So if you do this, it is going to work, but it's just in the air. It's not saved. So you just have to overwrite your data is equal to this. Now the result is saved back to the data. Okay? Now let's view the data again. So please, if you are adding a result to this, avoid putting view at the end. Otherwise, it is the result in the view that will be saved in the data. You are going to destroy your data set. Okay? So finish and then run for this line to see whether they change, or you can even check the structure, which is simpler. So before I run, you see that age, it is already numeric, means I run it. Okay. Yeah, so now the age variable from character is now a numeric variable. Okay? So, doctor, you are going to help us on this variable, the blood pressure. I know there is diatolysis or cis. Yeah. So we are going to yes.
The second, lower.
Yeah. Yes. So we are going to separate them in the systolic and that you have two different. And you know that maybe if it reaches a certain whatever you are belonging to, type 1, type 2. So you also help us on that. We are happy to have a doctor in the room.
The graduation of
Yeah, like if it reaches a certain level, moderating, yes. Yeah. We can rely on you or we can ask ChatGPT.
this is moderate.
This is moderate, right?
Yeah.
Okay. Good. So, yeah, if you are done here now, we have another problem from this. You see how the gender variable is behaving. Yeah. Are we all done here? Oh, I forgot him, man. J'ai demandé certaines infos. Ok. Il faut tester l'application. Puis, tu mets le lien avec. Hello? I'm not off. Okay. Okay. Let's continue with the cleaning. All right, so we can add as much as we can, like mutate functions, but only one is enough. Okay, you can use a single mutate, or you can just separate all mutates, by comma. So now I'm done with the age variable, yeah. Now I can add another comma, work on another one. If I don't want to have many mutates, okay, I can write everything in one mutate function. So now I can deal with another variable, which is gender. But before we deal with the gender variable, let's check what is inside the gender variable, right? So let's go down. Let's check what information we have in the gender variable. So now if I want to have counts in the gender variable, what function do we use? Have all counts. Counting categories in a categorical variables. Categorical variable. I mentioned it 2 years ago. Table, yes. So table and what? So if you want to do it in a fancy way, like using pipes, you can do this. Patients, you pipe it to what? Patients, you select. He mentioned it also. If you want to subset your data, select only one column, you can do select and gender variable. So if I do this, I'm selecting only the gender variable. If I want to select gender and age, I can do this. Yeah. If I want to select the fourth variable, it's also what? It's hidden somewhere. Where is it? It's not coming, so I'm lying. So any other, like a gender, age, admission date, if I want to add it to the, yeah, you see, you just use the main data, you select the columns you want, and then you can constitute what? A subset. Not a subset in terms of columns, right? And you can also have a subset in terms of rows using what? Filter. Okay. All of us have used Excel, so we were able to filter data. Even in R, we can filter data if you are operating on rows. So let me comment it because my interest is just gender. Okay, this is how to show you that we can select multiple columns from an existing data set, but my interest here is the gender variable. Now I can use my function table.net. Yeah, and it's clean. From the patient data, select the gender variable and count all categories. Normally, we should have male and female. Let's see the disaster. Capital F, small f, female with H. Well, Machibazu, we are going to clean this. Yes. I have an uncle in my village who has a pipe also, but he's not coding in R. He's using it to pipe things, in his body to smoke. You call it a pipe, a peep. Yeah, it's the same process. You just pipe things to your body with it. Right? You add tobacco and then you light it, you pipe it using the function inhale. It's the same spelling. It's the same. People pipe. That's good. I was secondary school. Papa female peep. Yes, sir.
What is the function of table?
Table is counting the number of categories. This is a category in the gender function. This is a category, this is a category. But how many times do we see F? 64 times. How many times do we see capital F? Even though they are the same. This one is seen 64 times, this one 56 times, this is 61 times. But everything here is the same category. And this is also a same category, but because we entered data maybe from different systems, we are having this kind of stories.
We are going to
Mutate them to harmonize. Harmonize so that we have male, female only.
so that I understand
Yeah. So yeah. Now we understand. Yes. So now we are going to have only two classes, female and male, and missing variables because we don't know what exactly is here. It detected empty. Yeah. So let's now mutate. So now you know that we have patterns starting with F. and some starting with M. And this is how we start solving our problem. If you see anything starting with F, it's female. See any starting with M, it's male. And we ignore the cases. So we use our grepl function. You know the grepl function I used like 2 months ago? Yes. Huh? This one. It was used like last month, this one. So now the pattern we are going to tell R, start with. The start with is also a regular expression that we can also give it to R, okay? So I want to always see things before I take action. So I'm going to use the grepl function like this, yeah? And this is how we do start with F. Start with is not power. The power sign now is start with, okay? Start with F. And where do you detect it? From this gender variable. So let me use the $sign. So it is going to detect true and falses. True means that female, false is male. If you want to see it clearly, I'm going to use it as an index because it is a Boolean variable. It has detected all females in the data. Anything starting, wait. I have not added ignore case because the capital ones are not seen. Ignored case is equal to true. Now it is bringing everything. Everything starting with F, capital or not, is there. Okay? And now if you want to start with M, is this. Now it will bring all entries about male. Okay? Yeah.
Nothing is good.
Start with. Start with. This means start with F. If you want to know everything that is ending with E, you use this now. End with E. If you use end, maybe the end is here. Ends with E. So anything ending with E, male, female, okay? You get the point? Start with is this one, starting with F.
What's that?
Huh?
How do you put that in?
The power sign we use on day one. Power.
This power is
Shift 6.
6.
Shift 6. This is the same power sign we use to calculate power of 2 or power of 3. This one. But now in regular expression, it is another story. Like 10 to the power 2, for instance. 100. But here it means start with. So now I'm just visualizing things. Like if I use this grepl in my mutate, I can be able to detect them and then assign a single value to all of these. Okay? Yeah, let's copy this. Yeah, I know. I want you to become a data scientist very quick. I'm eager to take you where I want to take you. Yeah, thank you for letting me. Let me give you another hint. You may sometimes want to break this chunk into two separate chunks. You just point in the middle like this, and you use the command shift. No, it's command alt I. Within a chunk, it will separate it. Hey, what am I doing? I've discovered something new. But I will deal with it later. But how will I make it disappear? All right. Okay, so you just insert Control Shift I. How do Control Alt I? Yes. You know, it is separating the two chunks. Yeah. Yes. In between, make sure there is space between the two. Good. Yeah. And another hint or another tip is if you want to remove like unnecessary space like this, you can point up and use Control D. Control D. And if you want to delete your code also, you can continue. Yes. Okay. Now that we know the problem with our data and we know how to access information, yeah, let's continue our pipe. Are we all good here? If you are good, we are going to clean the data from up and check down here whether the harmonization worked. So we are continuing with, but there is something I wanted to do. Instead of always working on overwriting the data, I want a new data. So I'm just going to run this. It's not going to affect any result. Okay. Now the data I'm going to have cleaned, like the clean data will be stored in patient so that I can keep my raw data. Yeah. Sometimes you may want to keep it for evidence or I don't know. Yes. This is the one I want to keep. Now if you want, you can add a new pipe and mutate gender now, or you can just add a comma here and mutate gender from here. It's up to you. Which one do you prefer? A new mutate or because that one people get confused. Make sure this is totally different and followed by a comma. What you have just done before the ending the end parenthesis of mutate. Before it, you put a comma and then go to the new line with another variable. Yeah? Is equal to. Now, here we are going to use another nice function, which is called if-else. I didn't cover the condition statements, if and else's, because I know I always had a problem with if, else, if, blah, blah, blah. People get lost, and even for loops. So we are not looping here. We are just using vectorized functions to avoid loops. Okay? So if else, it's just like in Excel. You test and then provide if condition is verified and if not. Now you are going to test whether the pattern starts with F. If yes, you overwrite it with female. Otherwise, it's male. Okay? So now, I'm going to break the line like this. Allow me to do that. You see, when you open the parentheses like this, you can break the line and have space to write your things. Okay? Now I'm going to grep starting with F from gender, and then I ignore the case. So if this is true, then call it female. Otherwise, call it male. You're done with the cleaning. But now we are playing a very dangerous game here. Now empty ones will be made. If you use this. The empty character will be male because we said anything that is not female will be male. This is what we have just said. So we can still control it. So let me just blindly say, okay, maybe R is kind enough to take care of the missing ones. You see, this is the problem I had. It is cleaned, but the missing values are all male, which is not right. So before we head into conclusion, like anything that is not female is male, we are going to write an if else in place of male. We are going to have an embedded or a nested if else, and if else in an if else. So before we conclude that anything that is not female is male, this one we replace it by another block of if else. So if else, it is starting with male, with M now. Plug it as male. Now the last statement will be missing. Okay? Yeah, it gets better and complicated at the same time. I already mentioned it. So we are not jumping into conclusion. So here, we are not putting male. We are going to break the line like this and add an if else again. So after female, we write another if else to check now for males. Okay. So we use the grepper function. If it is starting with M, from gender, ignore case. Then if this is verified, then it is male. Otherwise, it's missing. Yeah, now the code is clean. I hear no reaction from online side. I don't know if everyone is doing well over there. Please let us know. Should I redo something or should I? Can I start over?
No.
Is it working? Fine.
Maybe 10 minutes of break.
Yeah. 3 minutes. Water break. Or quick break. Yes.
So can you please shortly explain this line of code?
The if else.
Yeah.
So if else is the if conditions, if and else condition combined. So you are testing, like for each entry in the variable gender, if it is starting with f, irrespective of the case, right? It is lower or upper. Now, if you check in the gender and find out that it is starting with f, then change that value into female. Otherwise, normally, if there was no missing value, we have just written like male in place of this. But because we also have like patterns starting with male, and we have also missing values in the data. So the following will be very easy to understand, right? We detect also for male. If you detect for male, then plug it male. So anything left is anything. Yeah. Yeah. Just like in Excel, the if in Excel. Okay. So this is solution 1. I'm going to have solution 2, if you allow. And so another way of doing things. So I'm not going to use if else this time, but something else. Okay. So I'm just you copy from up and then you avoid using if else. So I'm going to clean up to here. Please don't forget to close. If you don't close, if you close a parenthesis, you will see the corresponding open one. I close here, it's for mutate, for us to avoid issues. So instead of if else, there's a fancy function called case when. This one. So let me make some space. Okay. Case when is also working with tests. I'm not going to write things from scratch. So if you test this in gender, case when this is detected in gender, replace it. So we use tilde, replace it with female. Same thing for male. Replace it with male. Now, just like in Excel, with the ifs function, so true, or by default, or if you want true means that anything else that is not verified up, replace it with any. That's it. Yeah. See, this one is clean. But if else, if you are not careful, one could die from it. It's not easy to debug, but this one is straightforward. The true here means that if all your checks up are not verified, they fall into the true, and then you override them into missing. So here you have many ways you can do this, or you can comment and have like default. This default use anything that is coming from the gender variable. This also instead of NA is bringing now the empty characters, the original one from the gender variable. Okay, if you check and replace things now by default, just bring back what was existing in the gender variable. Yes. J'attends. Okay. So what is the last thing we should do, since this is a categorical variable, male and female? What could we add here in the data? After the case when, what possible function can we use to convert? How do we tell R that this is a categorical variable? If you remember, factor. So before the, right after the, when you point the cursor here, you are going to see case when, which is telling you that this is the closing parenthesis for case when. So you can still pipe it to as dot a factor. Yes. Now if I run, now in the structure, now our gender variable is a factor with 3 levels. First level is female, second level is male, and the third level, first level is missing, second level is female, and third level is male. We have added a new thing here, right after the closing parenthesis of case when. So just to force the conversion of everything that is clean to a factor type variable. Oh, okay. If you want to view the data, or if you want, if you want to visualize it here in the yeah, here's the result. Okay. So empty characters are here, like missing. Those are Kenyan names. Jino Chino, Fatima Cheng. Fatima Cheng is like Ghana. Peter Kamau. Jean Niozima. This is Rwanda. This is just simulated data, but those names seem very realistic. AI is doing wonders. Now, the big problem we are going to face is this one, dealing with dates. It's a nightmare in every data scientist life. But in R, this is the reason why I love R. It's life made easy using a library. If you know how to use that library, you are safe. Okay? But in Excel, for those who did Excel with me, it was tough. Claudette, you were there, right? So I'm only going to display variables we worked on. So we worked on age, already we worked on gender. Now the next variable to work on is date variable, admission date. So, are we together? Can we deal with dates now? There's someone behind. Still. Can we continue? How can I say it correctly in Rwanda? Can we continue? Huh? Yes.
When we use this when
Uh-huh.
me, I found the transforming the gender as we talked about in having three levels.
Yes, I do have three as well.
But the first method, then I only remain with two levels.
Yes. For the first one,
It's only two as
I,
expected.
I will answer why. It is still three. It is still three because the NA is detected. Let me run this code. It is still three. Let me show you. If oh, okay. Because it is throwing out the NA. If I change NA into this, now it will be three factors. Yeah. Yes. That's the only reason. Yeah. So now, okay, it's there. Now let's deal with dates. As you can see, we have dates with hyphens. We have dates with the day name and the day and year, and we have dates with month, day, month, and year separated by slashes, and so and so and so. And the one starting with slashes also we see that there's one ending with 2021 and then one ending with complete nightmare. So let's start by dealing with easy ones, and we'll complicate our lives little by little. Okay? Check here. If we ask R, display all dates having hyphens. How are we going to detect hyphen? You already know the function. Huh? Sorry?
Special characters.
Yeah.
Using the two slashes.
Yeah. So if I want to detect all dates having this kind of pattern, how do I do that? Come on. How did we detect the space here? You don't remember? Huh? So we use greppo, right? I said hyphen. We want to detect dates that are looking like this. From where? From which variable? Patient, row, and then admission date. For us just to see whether they are having the same format, okay? So they're all here. And then if you want all dates with slashes, just change hyphen into slash, and then you see all of them here. But as I told you, those ones, there's no rule. There's one ending with the year and one starting with year. So we have to be very, very careful. So now if you want to tell R that this is a year, month, day variable, it's very easy because I told you there is a library called Libri Date. This is a lifesaver package for our users when it comes to dealing with dates. So if you don't have it installed, it's very simple. You just use install .packages, put the name of the package there. Then after installing it, comment it. Otherwise, anytime you will be running your code, it will install again and again. So for us to solve case by case, we are going to split. We're going to split our data into following the admission date structures. Then if you clean each of them, then we can now bind them together. All right. So we are covering things that all data scientists are doing, like merging data, splitting, then work on cases, and blah blah blah. Yeah. And for that, we are going to use another verb, which is not mutate, but filter. We're going to filter data. Yes. Now, how do we separate cases like dates with hyphen from other dates? So if you want, you can insert another chunk after this. So dates with dashes. So I'm going to take the clean version of my data, all right? And now this next function to have a subset of those dates with dashes, we are going to use the filter function. And filter function needs a condition. So it needs data and the condition. Data is already piped into the filter, so it sits where the argument data is. And the condition is coming after the condition can be put where the 3 dots are. So 3 dots means put any argument there, and it will be handled by functions like grepl and all those things. So I'm going to use the grepl function here again, grep-l. So I'm going to detect hyphen where in admission date. So that means what? Filter all observations with admission dates having dashes or hyphens. If I run this, you see the admission dates now? Yeah. So this could be saved in a new variable called patients dash. Okay. So if you run and then nothing is happening, it is because I'm assigning it to a variable. So it is silent. It's not displaying. But if you want to display and assign at the same time, there's also a trick. You highlight everything and then you open and close parentheses. Means that assign and print. Okay. So since we can isolate the admission dates, now we can operate on it. So let's add a mutate to this subset. Mutate. So admission date is equal to. Now we are going to use now a function coming from libredate. So that function now has many that packet has many functions. So if you detect that the first pattern here is year, followed by month, and those are days. Okay, year, month, day. You can just use the function YMD, year, month, day. So as you can see, it's coming from the libredate package. And you just have to convert admission date, but I'm very sure it is going to yell on me. It didn't. because it is a subset and I'm converting everything. So now let me display the head of patient dash. So now the variable now has changed into date. It's now a proper date, and there is no error. If there was an error, you will see that missing value introduced by coercion. And now it is done without any error. Means the conversion is done successfully. Okay. Okay. Now, if this is covered, we are now going to deal with another set of dates. Yes.
Yeah, that YMD, is it the pattern of the day should be a year, month, and day?
Yes. And then you also have others like year, month, day. If you have hours or minutes, seconds, you have all those functions depending on the pattern you are seeing. Yeah. You can even have day, month here, DMY, with hours, minutes, seconds. You can even have year, month, day, year, month, day, with hours, minutes, seconds. So all scenarios are there. Yes. That's why I'm calling it a lifesaver package. It's very, very useful. So if we replace hyphen now by comma, you see this kind of dates? Yeah. Now we have replaced hyphen by comma. So dates having comma. So we have month, day, year. Yeah. And luckily they have the same format. Yes. It's a good news. So you can filter data for comma and then use the Libri date, month, day, so MDY function on it. It will convert it to a date that R can understand. Okay. So patients, coma now. So note that I'm not saying patients that are in coma. So grapple, and now the pattern to detect is coma, admission. So if you run this particular code, you see the subset of data, tira. Uh, yeah, I've filtered data only for this kind of dates. Okay. And we are going to apply, so we are going to mutate now the admission dates. So what is the pattern? It's MDY. Yes, if you do MDY, month, day, year, on the admission date. Yeah, and R is not yelling on us, means we are okay. So let me display also the head of this. And you see the magic. Admission date was converted. The things we see with November is 11 now. But the struggle you had with Excel in this room. Left, right, middle. Hmm? It was too much. How are we going to deal with these ones? I suspect maybe there's another table with those people and their date of birth. I don't know if there's another table which can give us. Let me check. There is not. Okay, so we just remove the dashes, and then missing ones we replace them with what? Median or average. Hmm. In this format. So we have here, or maybe like November 27, 2022. Okay. Now, if you replace this by slash,
Observation.
mm-hmm.
Yeah, the date, I'm not seeing the effect of the date in the format of month, year, year.
Mm-hmm.
It still remains as year, month, and day for the patient with comma.
Give me a second. With comma, eh?
Yeah,
Uh-huh.
I'm saying patient with comma,
Mm-hmm.
like I run the code here and it's not giving me the format of month, day, and year, but it's still having year, month, and day format.
Yes. Actually, we are forcing R to have like the same format. Now it is year, month, day. And then for comma also, if you check, we got it from
Still year, month, day.
yes. So that when you merge, they will understand each other. That column will be the same as the other half. Yeah, we are going to merge now. Then our final result will be this merge with this. Now we are tackling the issue of, you see, we have one with there's one ending with the year, and then there's one starting with year. So we are going to deal with two scenarios. Okay. You remember the start with, right? Start with year. So in regular expressions, you can say start with 0 to 9 means that with digits. So how many digits do we want? We can put a curly bracket and say from 1 to 4. What did I just do? And followed by okay, wait. Yeah, let's say start with man. How do I change this one? Maybe it is not 1-4. Let me try this. Yeah. Okay, so I was able to detect only the one starting with the year. So this is also a regular expression which says starting with numbers, and we should have 4 numbers before the slash. Okay? So we start with numbers and we should have 4 characters before slash. So it's going to detect, let me remove the head 30, it's going to detect all those scenarios in the data. So as you can see, it is also a year, month, day, because there is no month that can exceed 12. So if you see something exceeding 12 at the end, means that the day is the last. Okay? Yeah. So this is another case. How are we going to name this one? How are we going to name it? You have a question? All right. So I'm going to just give it a name, like patience. And now, how do you call it? Slash, yes, slash, yeah, slashy. Slash, but starting with the year. Okay. So we filter patience data, filter, and then we are going to write our grepl function. So allow me to break the line like this. So I write grepl. Now we use our wildcards. So starting with numbers between 0 and 1, 0 and 9, and get the first 4 characters before slash, or followed by slash, and where in the admission date. So it could even sit up here. You still have places. I was wondering whether it could fit, but it could. So if you visualize the head of this data, yeah. So now we are going to apply a function from the libdate package to also arrange this. Okay. So let's mutate. Admission date for this case is equal to, is also a year, month, day. YMD admission. So R is silent, didn't say anything bad. No warning means yeah. So now the same format. Yeah. Yeah, I've just seen something. Sarah Uwase. She is normally a female. Her gender is missing. Since we have few cases there, we can just say, okay, if you also encounter Sarah, then change the gender into female. Okay. This is not right. Moses Uwase, a female? Moses Uwase. Moses Uwase can never be a female. So how comes Moses is coming here?
No, their name is that.
Huh?
You can be called Moses only a female. It's very possible.
Where? In Rwanda?
No, not in Rwanda. In other Africa, in other countries, not in Rwanda. Maybe European countries.
A lady called Moses. Okay.
It can be the first name when the first name is Moses as that's his name.
Okay, let's assume that it is true. And then we continue just like that. It is simulated anyway, so no worries. Okay. So now, can I give the last one as an exercise? The one ending with the year. End with 4 patterns after the slash. What is the change here? Yes. Sorry? So it has slash, but ends with 4 numbers. So we have to begin with 4 numbers and followed by slash. Ends with 4 numbers, but after a slash. How do you do that? Huh? So you said dollar sign. Dollar for end with. Yes? But the dollar sign should be at the end. Then we have a slash. How do we now say after slash we have 4 numbers? Yeah. Square brackets. 0, 2. How do we say it is 4? Are you sure? Yes. You are sure? You see? So it starts with, so we have it means that what? Ends with, but the starting point is a slash. That's just to force that we must have a slash in the date, and then ends with the year. So 4 digits at the end. Yeah. So now this is, you see 26 means that this should be day. Day, month, year. This is a day, month, year.
Yeah, there's the problem which is being solved.
Oh, okay. So can continue. You have a for the Python. No. Now I see it. The comma is monthly. The comma? Comma is monthly because it starts with November. Yeah, that's it. So be careful. If you apply the wrong function, you have to detect the pattern visually. If you apply the wrong function, it is going to mislead R, and then you get NS. Yes. So now we have a group of like admission dates starting with day, as we just detected it up here. Day, month, year. And the pattern to detect it is this one. So we detect patterns where we have a slash and 4 numbers at the end. $sign means ends with this pattern. Slash and 4 numbers. A slash, 4 numbers, this, ends. And the dollar at the end means ends with. Okay? Okay, so now the same thing, I'm going to put it back. I'll put it down here in the filter. So we start with our patient data, pipe it to a filter, then greppo. So the pattern should end with slash, then numbers between 0 and 9. So 4 of them, which means ending with slash and year. And this $sign means end with what is preceding. Ends with slash and 4 numbers. So where do we detect that from? It's from the admission dates. So once the detection is done, or once the filtering is done, then we mutate. So now, what is the correct way of writing this now? What do you see out there? Which function from degree date we should apply on the admission date in this filtering? Yeah, day, month, and year. Yeah, DMY. And then on itself to force the conversion from string to date. Now, no warning from yeah. Imagine if you use a wrong function like year, month, day. You see how R is yelling on you. It's throwing warnings. And now it's not only warnings, if you check the result, everything is null, missing. So you have to use the wrong function to ease the work. So day, month, here. So no yelling. And if you want to check what is it, so it's well converted. Okay. So now how do we put everything back together? If we, let's assume that we have covered all types of dates. Is there anything remaining? Is there any? Let me check. Let me look at it like closely. I think there's nothing else. Yeah, there's nothing else to worry about. So we are going to merge them, and if the number of rows match the number of rows of original data, then it means that you have covered all cases. Okay, so now what is the function to merge data back together? Merging is merge. We do have a function called merge, but we are not going to use that one. We are going to use sophisticated function, which is bind. Which one do you use? Bind rows or columns? You use bind rows or columns if you want to bind filter rows. Yes. Yes. No, the end result is the same format. So we are bringing different formats into one format. No, the original format is they're different. Like you have like 1, 2, 3, 4, all different formats in our original addition. No, when you do mutate, the result is one format common to all of them. Maybe I'm not understanding. No. You know, we are making changes, but in those subsets only. It's not affecting the patient data we started with. We are using it in subsets. We are now working on subsets, but now we want to reconstitute, like put them together. Yeah, we have 4 subsets with admission data cleaned. So if you don't put them back, don't think that why because you are working with the patient data, it is also doing the change over there. It doesn't. You are just using it in our subsets. So now we have to bind this, and the last one together to now get fully cleaned. So as Colette said, we are going to use the bind row function, and you just have to copy these elements in it. Okay, so if I hit enter, I've not saved it. It's just running in the console, but I have to assign it to if I want, I can assign it to patients again to override patients. So as you can see, it is accepting because all of them here have the acceptable date format. When you apply like DMY, YMD, the end goal is to have year month day for all admission dates. Otherwise, the binding will not even work. So now I'm going to override this into patient dates. Sorry, patients. Now for me to be sure that I covered all cases, let's check the number of rows of the new data, and now the number of rows of patients row. Yeah, so they are equal. So means that the same data that is here is found here. We have 600 and something. Yeah, 611 in the result of like in this result, and even the original data is telling us that we have 611. Did I answer your question as you want? So if you want me to make it clear for everyone, her question was, why are we mixing year, month, day, year, year, month, day? Why are we mixing them? It's from the detection, like the last one. If we detect dates that are finishing with slash and year, we observe that, like 27 is the day, right? 606 is the month, and now it is the year. That's why for the last thing we did, we used the function day, month, year, because it is starting with day, and in the middle we have year and yeah. And now for the dates, following this pattern, if I replace it up here, means that all dates starting with the year. Now the format has changed. So we have year, month, and day. So it is the last, the second last. Second last is this one. We use the year, month, day to convert it. So just to tell you that after using those functions, the end result is similar. So if I run this, why is it doing this? If I convert the understandable date format in I don't know what's going on here. Yeah. So what I can understand when you do, they're hidden down here, I don't know why. So let me just view it. Why is it empty? Oh, I know why. Actually, that case no longer exists because the final, I use the variable name. So I over, the problem has disappeared. That's why you find nothing. So if I want to see it again, I have to run from this. From the beginning, yeah. So let me write from the beginning. That was Jacob, Jacob Zuma, from the beginning. In the beginning. Yeah, so the result gives you, this is what I understand. The dates in R start with year, month, and day. So you can bring any format, it will come back to this format. So a unique format for all cases we dealt with. Does it answer your question? I think it is yes. Yeah. So now we have also checked here that the number of rows in our clean data is the same as the number of rows from the original data. Then it's a check that is telling us that all is good. So let me stop not stop. Let me give you some moment to finish this. And then we are going to deal with another variable. And when we get back from lunch, I think we are going to do summary statistics, grouping by. If you do summaries, then the following thing is graphics, stats. So if data is clean, doing graphics is less straightforward. Yeah. Yes, draw charts. Yeah. And bosses who have never dealt with data, when they recruit you, the first week they want to see graphics already. And you find excuses that I'm still cleaning data, but what are you cleaning it? Using a soap or I don't know, javel water? Or how are you cleaning it? We need results. This is how they are. They don't understand that when data is dirty, any statistic you provide is wrong. Yeah. Do you need more cleaners? So we are training ourselves here to be professional cleaners, data cleaners. If you don't put data, then yeah. And the funny thing is that people start their work without considering any statistician, any data scientist, but when it gets worse, they have to call someone to come and do magic. Always like that. Instead of starting a project with a data scientist, we ignore. No. Vuba ukache. Yeah, our program is becoming very common. Oh, it is Jewish.
Now the question is, how was this method?
Now you have told me a very nice one. You are very
I have this I find this fascinating. But can I see like the applications in the past and be able to use it in Excel?
So let me reframe your question. Your question is, after cleaning, can I be able to save it in an Excel file? Yes. Yeah. Yes. So after cleaning, you can save it to an Excel file and still use Excel for graphics. Yeah. Yes. And the library is Write Excel. So you can install this. Write Excel. Okay. If you have it already, you can use library Write Excel. So this one, if you finish the cleaning, you can use now the function Write Excel XLSX. Yeah. And then your patient data will go in it. Patient data, and then you can use the path now to save it wherever you want. That's it. But let me not confuse the other people. And we are going to use it anyway. Huh? Yes. So let's finish the cleaning, and then saving data will be easy. I was just answering the question of our sister Colette. Okay. Yeah. So her question is, now that it is easy for me to clean data in R, can I start cleaning data in R, save it in Excel, and continue from there? Those are the questions that I really like. Means means that, yeah, it's tough to clean data in Excel. So if I can do it in R, I start with R and then write it in Excel and continue from there. If my boss is very comfortable with Excel, yes. Yes, yes, yes. The important thing is to know libraries. There is the Open XLS. Yeah, the Open XLS can help you start an empty workbook and then save every summary table into sheets. Like you start from R, but the end goal is having Excel. An Excel file is different sheets, and every sheet, like a first sheet, can have like the original data, second one clean data, third one grouping by. Yeah, but I don't know if you can also insert graphics from R to Excel. Maybe someone already did it.
Excel graphic.
Yeah, like you write a code in R that triggers a digit plot in I don't know, like maybe a plot in combo plot in. I don't know if it is possible, but yeah, that will be my conversation tonight with AI to see whether there's. Yes, that one is possible. Yes. You can create a graph in R and then put it in Excel. It's also possible. And also, yeah, if you want to interact with Office, there's also Officer. This is also a package. Yeah, Colette, all those things will be touched. Let me not confuse other people. So, are we all good here? I see other colleagues still working. All good? Is all everything working? Doc. Is it? Wow. Ça marche. Ça, c'est super. Comment Bandou? Ça sort. Ça marche. You are from Nigeria. Liberia. Oh, George Weah. Mhm. How come? Oh, yeah. Oh, yeah. George Weah. The Ballon d'Or.
Ballon d'Or.
Yeah.
Yeah, one and only.
The one and only, yes.
Up to now.
In Africa, right?
Yeah.
They refused it. They didn't give it to Eto'o. Yeah. Okay, so let's check again the structure of our data to spot some additional problems to tackle. So now admission date Can you see the data type? It's now date. And we have a unique format now for all dates. Okay. Now we will need the help of our doctor to help us rename, because I'm going to use a function that will split the blood pressure into two different variables. So he will tell us how to rename them. Okay. So we are going to use the separate function, separate. To split our column into more than 2, provided a pattern. So, yeah. So what is the provided pattern here to split those two numbers? What is the pattern on which we have to base the splitting? Slash, forward slash. Okay. Separate. And this one is coming from the package code named tidy up. You see, tidy. Tidy means from dirty to clean. Tidying. Tidy data. So the separate function needs the first argument, which is the data. So it comes from blood pressure, and we convert it into, okay? Convert it into what? Then we provide the names as characters. So the first one you said it is C what? Systolic. Systolic, like this? Okay, this is the first one, please. Here? Guys, let me go search. What's the meaning of this in blood pressure? What is systolic? Yeah, systolic pressure and diastolic. Yeah. So now AI is even telling me like 175 systolic. The top number measures pressure when you're a reading of 140 or higher. Oh, so it's meaning that if you have 140 or higher, it is stage 2. Means that you are having high blood pressure. Wow. Now how will I know mine? Okay. All right. So now systolic was well written. Now the second one is diastolic. Okay. Okay. So what is the opposite of separating? Unite. Yeah. So on the other hand, we also have the unite function from tidyr. You have separate if you want to separate, you split them. You have the unite if you want to unite. And then you provide also the pattern. Now we have an additional. It is asking you whether if you separate, will you keep the original one or you remove it? So remove by default is true. So if you say remove is false, then it's going to keep the blood pressure variable. Otherwise, the blood pressure variable will disappear and leave place to systolic and diastolic. So let's check it. Remove is true. So now check. If you check here, where is blood pressure? So you see, we have systolic and diastolic. So remove is true, means that the blood pressure variable just vanished. So if remove is false, now after admission date, you are going to see your blood pressure, okay? And with the separation. So choose. So I've provided, I didn't provide any separator. So sometimes you need to provide the separator using sep. So I can say this / okay? But if you don't provide it, R can also detect the separator. Now it was detected, and then you have now two numbers well separated. Yeah. So can we come up with? It's already one pass. Yeah, first one. All right. So let's stop here and then let's go have lunch. After lunch,
Sir,
I'm going
can
to
I ask
take
a
you.
question?
William? Yes, please.
Can I ask a question?
Can you ask it after lunch, please?
Okay, no problem. No problem.
Yeah, because we only have 1 hour and we may end up being late here. So if you can answer it from 2.
Okay.
Ask it from 2, please. Thank you.
Okay, no problem.
So since
De cleaning age variable into patient row là. En fait, là j'étais un peu perdu parce que j'avais des problèmes de connexion. Je voudrais que j'ai
est-ce que vous
un
pouvez
problème là
répéter, s'il vous plaît?
dans ma commande.
Répétez un peu, s'il vous plaît, monsieur William. Vous dites?
Je disais que au début, à partir de cleaning age variable into patient row, row using mutate, genre j'étais un peu perdu quoi.
Ah, vous étiez perdu sur le mutate, ok. D'accord, il
Ouais.
n'y a pas de souci. Je vais refaire un. Je vais refaire un exemple et puis tu comprendras le reste. Ça marche?
Ok. Ok,
Et je peux aussi copier le code et je te le dépose dans le chat. Comme ça, tu peux aussi.
Ok, pas de problème. Ok.
Rattraper. D'accord.
Ok.
Hey, someone has connected himself to my earpiece. Someone has taken my control of my. I don't know. Hey. You know, it will be very hard to reconnect. Let me do it first. Bro, please, I don't know. Maybe it is your computer. No, it's the it's the iPad. Sorry. All right, fixed. Let me get it here. Connect. Fine. So, Mr. William, je vais répéter. Je répète en français ou en anglais?
Bon, en anglais, français, ça ne dérange pas, peu importe.
Je mélange les deux, hein?
Oh, ok, il n'y a pas de problème.
Ok, je vais faire l'anglais. Donc, tu vois la première date où il y avait... Si tu comprends le grepl cherche le hyphen, tu vois. Bon, je vais aller en anglais. Grepl is looking for the pattern hyphen in the date. So this is the entire vector of dates. You have like, it's not displayed in the classroom. Donc, je veux aussi que les gens qui sont sur place puissent aussi suivre.
Okay. Est-ce que c'est possible, qu'on puisse remonter au niveau de la partie où on a créé la variable patient là, à partir de patient row?
La variable?
Patient, ouais, c'est bon, voilà, là. Another way of doing it là. Oui, c'est là.
Ici, hein?
Cleaning data. Oui.
Ah, c'est ici que tu es perdu.
Ouais, la partie là d'en haut là.
Ici?
La partie
ici.
d'en haut. Oui.
Oh, ok, en fait, cette partie, tu vois, j'ai dit another way parce que cette partie est un peu plus compliquée que celle-là. D'accord? Voilà. Maintenant, je veux que tu comprennes que dans le if, tu vois, non? Tu fais un test, n'est-ce pas? Maintenant, après le test, si c'est true, si c'est vrai, ça reste là. D'accord? Si c'est faux, en fait, tu as des choses ici. Donc, si tu veux, je peux te réécrire le if-else. So, if-else, si tu veux, par exemple, tester que 10 modulo 3 égale à 1. D'accord? Si cette allégation est true, qu'est-ce que je suis en train de faire? Modulo ce double. Hein? Si ce matching, ce test est true, then tu vas dire que 10 is not a multiple of 3. Otherwise, 10 is a multiple of 3. Tu vois un peu? Tu vois, on a fait voilà. J'ai tourné la fonction. Maintenant, le résultat, c'est 10 n'est pas un multiple de 3. Parce que ce test-là est vrai. D'accord? Maintenant, si à la place de 10, j'ai un x, maintenant, je dis que x est égal à 30, par exemple. Donc, si j'entre x en mémoire et je rends encore le test, on va dire maintenant, voilà, ici, au lieu de dire 10, je peux dire x. OK? Donc, si je rends, ça veut dire x maintenant est multiple de 3. Avec le if-else. Donc, si la condition est vérifiée, ce qui va apparaître, c'est ce qui est ici. Si elle n'est pas vérifiée, c'est le deuxième message qui apparaît. Tu comprends un peu?
Ok, donc c'est juste pour les trucs de condition.
C'est les conditions, en fait.
Oui, ok.
Voilà. Maintenant, nous, on est en train de tester ici. Si on teste, on teste une entrée, une catégorie, et ça commence par, tu vois, le chapeau ici signifie commence par F. Maintenant, le ignore case means, elle veut dire si c'est grand F ou petit f, faut ignorer. C'est la même chose. Petit f et grand F seront les mêmes, d'accord? Donc, si tu trouves une entrée commençant par F, il faut maintenant la changer. Ça, c'est maintenant, c'est le is true, tu vois. Si c'est vrai, si ça est vérifié, remplace ça par femelle, n'est-ce pas? Female.
Ok.
Maintenant, comme on a aussi les valeurs manquantes comme celle-ci, on ne peut pas dire directement que si on ne trouve pas femelle, il faut mettre male ici. Ça sera faux parce qu'on a aussi des valeurs manquantes. Donc, à la place du second de mâle, maintenant, on doit encore faire une autre vérification pour
les mâles.
Pour les mâles. OK? Maintenant, si c'est vérifié, on met mâle. Sinon, ça veut dire que ce n'est ni femelle ni mâle. Donc, c'est manquant. Voilà pourquoi le dernier ici, on met manquant. Ça, normalement, si tu connais le conditionnement, c'est facile. Easy.
Ouais,
When you
c'était
know
un peu
about-
et puis le muté qui m'avait un peu mélangé, quoi. Sinon,
Oui, oui.
c'est bon.
Maintenant, le mutate. So mutate, if you use a variable name that is existing, then you are modifying it. You are transforming it. Now, if you are using a variable name which does not exist, then you are creating a new one. So for the case when is very straightforward. You just test all entries starting with F, and then you flag them. This is flagging. Flag them as female. Test for male, flag them as male, and then by default, you take anything that is coming from gender, which does
What
not
about the
obey. Sorry.
as factor?
As factor is the same as numeric that we did somewhere. You see, we
Just
did
down.
one conversion.
Yeah.
Yeah, up here.
Numeric.
It's the same. After the G sub, we sent it in as numeric, and this one is the case when. Everything here is in the case when, and then we send it into a factor after we finish the whole process.
Ok.
That's the same. Yeah.
Ok, c'est bon. Merci beaucoup.
And it could, ça pouvait être aussi une seule ligne comme ceci, mais comme on a beaucoup de choses, voilà pourquoi on l'a découpé en mini morceaux.
So, ouais.
C'est bon?
C'est bon déjà, ouais. C'était juste cette partie.
Ok. D'accord. Ça, c'est très bon. Et ça me rassure qu'en ligne aussi, vous suivez.
Ok.
Ouais, ouais. So now we were able to separate blood pressure into two. So now let's check the structure again of. Okay. Have we saved anything? We did the separation of blood pressure into systolic and diastolic. But we just sent it in the console. We didn't save anything. So if I want to overwrite my data, I have to do patient is equal to the new version of it. Yeah. I take the same data, I do the separation, and then I send it back to the data. So now I'm not losing anything. Okay. So let's check the structure of the patient data. So I'm going to run here. Can you see some problems you have? Okay, so we also have like missing values in like 59 rows. We have issues. So let's check what exactly is happening in those 59 rows. Okay. but this move was deadly. It's not good at all. Um, tut, 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 tut. So I would advise you to run from up. Okay, load the data. I did a very bad move. Now I cannot retrace what exactly happened. So let me import and then run here, run here, run here, run here. All right, if you're done here, then so for this one, I'm going to call it maybe v2. Okay, version 2 of the data. So that even if I'm to go back, I should not go back again to run step by step. So this, anytime you see this kind of warning, it should trigger your mind so that you go and check what exactly is happening. Okay, now I get this error, and they say that in either systolic or diastolic, we have issues. So I'm going to check again in patients data, and then let me start with systolic. No, patient blood pressure. So I'm going to see why we have any in patients V2 and then systolic. We don't have, means that the problem is in diastolic. You see? And this is actually good. Means that we were having missing values from the start. Huh? It's good to check always. So if they are converted into NA, this is a good news because they were even missing from the start. Okay. All right. Even if instead of a patient, if I even check the raw data, will I have the same? Oh, okay. In the raw data, I don't have the same. So what exactly happened? No, 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 no. Uh-oh, don't, let me not get you confused. The position changed in the filtering. So there's no point. I cannot check the row here, the raw data here. It's just, we were operating with patients. So they were missing from the start. If I want to check from the row, I can say, okay, what is the sum of patients row, and then blood pressure is equal to empty. Yeah, there are 59. So we had like 59 empty characters from the raw data. And now let me also get the length here. They're also 59, which is confirming that I already had those empty things from the very, very starting point. So we always check. Mm. So don't worry, if you get a warning message, it's all good. Okay. Let me also check this one, diastolic. So since there are still characters, systolic is equal to this. Sorry, I don't have any missing. What is going on here? Who put the X? 59, I guess. Yep. Now I'm happy. I was worried. So here, if you want to get rid on the warning, just after R up here, add warning is equal to false to silence that warning. Okay. Mhm. Let's check the structure of the patient V2 data. So by solving one problem, we created two. What are the two problems we just created? We wanted to solve one problem, we created extra two problems. So systolic and diastolic should be numeric variables. Now they appear to be character variables. So it's easy, right? How do we change their types into from character to numeric? As numeric. So we can directly add a pipe here, right? And do mutate. Yes. Let's add a pipe, mutate after separate. So systolic is equal to as dot numeric systolic. And also diastolic is as dot numeric diastolic. So those two tests are not going to help us again. Then let's check the structure. Now we have numeric variables and missing values are now NNs. Okay. My fuel is empty. Okay, now is it clear for everyone? So since we separated two character type variable into two, then we get also as a result two character types, but they are normally numbers. You can simply convert them into numbers. This is the simplest mutate you can get. Okay. So instead of doing str, I can also check the head of my data. While you are typing, I'm also trying to see which kind of problem you can solve. Now systolic and diastolic are numbers. Treatment cost should be also cleaned. As you can see, you have a number here and then there is a dollar sign. Yeah, so we can also get rid of the dollar signs and anything that is preventing us from doing the conversion from from character to numeric. Mhm. So let's agree on one thing. If we reach the variable outcome here, I want to start analysis so that the leftovers, I will leave it to you as exercise. You continue the cleaning, but I'm going to stop at outcome variable, and then you can aggregate data and do visualization. And the remaining, you can do it at home or with Cassien. Okay. Isn't it? Is it a good idea? Okay. Doctor, is diastolic and systolic related? Is there any strong relationship between systolic and diastolic?
Some pathology called sepsis.
Sepsis.
Yeah, where is the difference of systolic and diastolic is under 65 milliliter mercury. We need to warm
The patient.
patients and we have to act quickly.
That's the story.
This is an emergency situation.
Okay. My question is, if I have like 63 in terms of diastolic, can I expect to have less than this? Like if this can play a role on the first one.
I can explain why this systolic.
Uh-huh.
Why diastolic. Systolic when the heart doing this contraction. Systolic. And he push away the blood
in the whole body, yeah.
And when he relax, diastolic, he takes some the blood to purify.
Purify. Okay.
Yeah. So
Yeah. Let me try something. I just wanted to know whether one variable can, if there is a correlation, hmm? Correlation between, yeah, if you select systolic and the diastolic. I know it is fake data, but oh, no,
there's no correlation.
there is not. Yeah, means that you can have different stories. Like you can have a small diastolic, but it doesn't give you an indicator on this the systolic. C'est pas en ayant un grand systolique que vous pouvez prédire que ce gars-là va avoir aussi un grand diastolique. Voilà. Ok.
Sauf que la situation, par exemple, les sujets âgés,
Mhm.
le sujet âgé a beaucoup plus les diastoles est beaucoup plus élevé
Que
les systoles est beaucoup plus élevé
que les jeunes.
que les diastoles.
Ah.
Mais aussi, il y a une gravité, si les diastoles est élevé,
Uh-huh.
c'est grave.
Ok.
Que les systoles.
Ok. Wow. I'm learning something also. Hein? J'essaie de comprendre. Ok. Let's clean the costs, the treatment costs. So why is making the variable which normally should be numeric character is because of those characters which are not numeric. So you know how to, can we give ourselves like 5 minutes to remove the dollar from that cost? Please try. Can we add a mutate here to clean now the treatment cost? Sorry. Let me isolate that variable first. This is the treatment cost variable. Is it only the dollar sign which is bringing problems? I don't think so. Check very well. We have also those commas. Where is it? Comma separators. This one? Yes. So R doesn't understand. And then it has even two problems. Dollar and comma. What else do you see? Negative sign is okay, can be understood. But how comes a cost can be negative? Eh. So we are going to remove negative, dollar, and commas.
But negative it can be.
How can I get like a negative bill when I go to buy to
Yes.
negative?
Give you a
No, it doesn't happen in real life. No. Maybe it is your friend's hospital. No.
So what if
In this economy.
let me tell you, what if there is like an accident? So are they going to take a patient like you have to first pay, or they are going to treat her or him, and then the cost is going to be calculated after? You know what happens in Rwanda when they make an accident? You know what happens? I'm asking. I guess like. No, you know what happens?
Answer the question.
situations. No, there's no situation. We are talking about one. Make an accident. And then someone takes to the hospital. What happens? Someone who takes you is responsible.
Oh.
What?
Like someone who took you to the hospital.
He's not responsible.
Yeah.
For it. That's why you can let that stay before you die. If someone takes you, you are not to be responsible for that. It's crazy, but
They are going to treat you, but you are
no,
accountable.
they can't treat you. You have to pay. You have to
Pay. Uh-huh.
Those people who
Yes.
have the money,
pay in government like that.
But no,
Yeah, you didn't know by doing.
And you are losing people. Eh?
it depends on the fees.
No, you don't.
And the system.
Hey, but I looked at them, you take a person.
Yeah, we know. When patient come to me, I have to evaluate.
Mhm.
There is vital emergency.
Mhm.
Or no.
Mhm.
If there are vital emergency, I have to take it immediately.
Mhm.
But there is no, if I evaluate and there is no emergency vital,
Mhm.
I can then give that to take a good for money.
Mhm. Mhm. Or you stabilize the patient.
Yeah, so that.
Yeah.
In Rwanda is different.
No, it's not.
Mhm. No, it's not different. We went last time to King Faisal with a Chadian who, like, I don't know what happened. Like he just collapsed and now lost even the motricity of his arms and legs. We took him. They took to King Faisal. Yeah, he got treated. I don't know. It is where maybe they called me and then they promised to the doctors that someone is coming with the money.
Another thing is, he was a bully. He was a bully.
Okay.
No,
Uh-huh.
Quand il y a urgence vitale,
Oui.
on peut pouvoir traiter. Si ne traite pas, mais ça fait chaud.
Mais on l'a traité. On l'a traité, je suis venu même très en retard. Ouais.
Allez chercher la salle.
Actually, okay, it's a good debate, but let's move on with So the GSAP, c'était juste pour nous galvaniser. The GSAP function is the one we should be using to substitute any pattern that you don't need. So we have like 3 patterns. We are not going to write three GSAPs. GSAP can take all those 3 patterns together, detect them at once, and do the change. Sorry? Yeah. So in GSAP, you can do this. If you find hyphen, okay? So now that the problem of negative is solved by our doctors, there's no negative bill. There is not. If you encounter hyphen or dollar or what, comma. So when you put them in square bracket means this one or this one or this one. The same as 0 to 9. Like if you find numbers between 0 to 9. So it is 0 or 1 or 2 up to 9. This one it is hyphen or comma or dollar. Okay? Yeah, dash, comma. If you find it in the column of what? So if you find it, replace it by empty value, empty string, but where? In course. But I'm not going to try directly in the GSAP app here. Sorry, I'm going to drag this down here. I want to make it work on this first. Yeah. Yeah. It's like it is working, eh? Yeah, it detects those 3. Yeah, and then removes them. And now we can convert into the app. There's nothing else left. You see? Yeah. Yeah, this one is, yeah, if honestly, if you want to do it that way, it should be like this. Hyphen is recognized. For comma, you have to do double, and this one should be like this. This is the same thing, but you have to do double, which doesn't make any sense. So this is the right one. So now that we have seen that those special characters were removed, we can convert as numeric directly. Now there is no even an error message. Then we have moved from dirty data, we removed the unnecessary patterns, and we were able to convert it into a number. I can even send it into a histogram if I want, or a box plot. You see, I clean the data and sent it directly in the box plot, and you can see the distribution of your data. Yeah, pink color is better than blue. The color of ladies. So we can simply write treatment here, since we are convinced that everything works. So this mutate is going to work also properly. And the missing thing here in the mutate is as dot numeric. Finished. I need an energizer. Let me go snatch some. I'm going to steal some sweet. Merci. Sorry, I have to send an OTP to someone to access the platform. Sorry. Oui, je vois pas là. Je ne vois pas. Tu n'as rien envoyé.
Ah ouais?
Clique sur le truc, je t'envoie l'OTP. Tu n'as même pas fait. Je viens de vérifier là.
Ah,
Ok, c'est bon. Ok. Dukomeze. Can we komeza? Huh? Hagarara. Hey, Hagarara, I learned it from Busanza. Driving lessons. Hagarara. Soka. Is it Soka or Shoka? Soka. Mafande. Mafande is police. Soka. Hagarara. So what is the next variable we can focus on? Or I should Can I say Hagarard? I should not move, right? Hagarara. Are we having issues? Can I have a look? Let me scan. Sometimes from the error, you can see the problem. What does it say?
For drawing. Coast. Cannot be coast to take double.
What, are you trying to do what? The histogram?
No, we're trying to check to change it as numeric.
Hit it. Doesn't work.
It is working now.
Yeah.
It is okay. But still,
No, this one is normal.
Yeah,
it is when we were separating blood pressure into systolic.
to build now history.
Yes.
What if I do as dot numeric? Is it going to? That's where we have to so that they can do histogram.
So, are you piping the entire data into as numeric? No, it doesn't work like that.
Okay. I have to select
Yeah.
treatment.
No, but since you are saving it back to the main data V2, then it's not a good idea. You clean it. Clean this. Even the pipe. Add a new line. New line. Yeah. Now you can use the variable name here. Where is it? Yeah, the patient V2. Then you can use histogram, hist on. Oh, you can, yeah, dollar. And then
Treatment.
Then you pipe it to hist. That's it.
Okay. Has to be numeric.
Hey, you didn't do as numeric somewhere here. You didn't.
I didn't.
Yeah, add as numeric here. At the end. You get error?
When we do.
No, not here. Before. Wait, it's here. No, why comma? Remove the comma. Just pipe it to as numeric. Dot numeric. Enter. That should run the entire thing. Control enter. And then histogram. Enter. Yeah. Yes. Yeah. Okay. Now the next variable is let's check the head of this. I didn't run everything. So now treatment cost is treated, transformed. So now we are left with smoker, and for today I'm going to finish the cleaning of smoker. After smoker we do outcome, and then we start analysis as promised. So let me clean this one. So we are also checking whether our patient is a smoker. So we have a system problem here. One system is recording data like 0 is non-smoker, 1 is smoker, n non-smoker, no, imagine with lowercase, no with N capitalized, yes, which is presented by Y and so and so. So we also have a harmonization problem here. Okay. So it's just like treating the gender, right? Can you tackle this problem? I give you like 5 minutes. I just need 2 classes at the end of the day. Yes or no? So mutate, I'm going to write some of the code and then leave it to you. Case, no, so now smoker is equal to case when if smoker is equal to 0, then if it is 0 means no. Yes. So this now is this. These two become the same. Huh? Uh-huh. Uh-huh. You see the genius. You see this genius? What is doing? Yeah, he's saying if we say, for instance, we add a mutate, another mutate here, we say mutate. Now smoker will be equal to upper, right? And we capitalize everything. It will solve us many issues. So let me just delete this one first, or comment. So if I do this one and come back to the table, you see the genius has solved us lines of codes. You see, we have things already solved. So we are going to now just change the 0, the 1, the N, and the Y, 4. But before, we were having the problems of upper, lower cases. Now the problem of upper and lower cases are solved. Very good. So if you want to capitalize a variable, is to upper. If you want to have lower cases, is to now to, huh? Yes. Why are you afraid? Yes, to upper, to lower. Thank you, Blanchard. Now I can pipe onto this and continue with this information now. Can you solve the rest? So 0 is no. Then what else? So how can you combine 0 and n? So that, please, make me proud. Why? Why are you saying it? You are an expert. So we are going to use the in. C of 0 and no. And n, yes, yes. Come again? It's good, right? Yeah, this is good. Yeah.
But at what is where we have double N.
Double N.
Capital letter N-O. It's better to turn it into where it is capital N.
You mean this one?
Yes.
This is what I'm overwriting everything with.
We are saying where we have N. No, with capital letters for what is. If we say where it is,
Yeah, you are right. So you also add Enu
yeah,
in the list. Yes. Yes. The same for yes. Yeah. So now it is 1 y and yes. Default. Yeah. Sorry. To yes. Default is equal to keep our missing values. Default is given by what? Come on. Default is everything coming from smoker, right? Yeah. Now let's run. Yeah. So we have no and yes and 64 missing information. Hmm? Hmm? Yeah, it's function operating on columns, on rows or columns. Yes. To upper. Like if you have names like this is what it does. And then if you pipe it now to lower again, it's lower. Yeah. Yes. Yes. Deceased, ongoing, recovered, Rachiri. Hmm? There's a Kinyarwanda word that I thought maybe people were very angry with me, like Mufashi. Mufashi. Like, I want to help you. Pourquoi tu es fâché? So I thought maybe someone is angry. Fashi, help. Comment? The error is saying what? Hey, your R is in French. Symbol inattendu. Comment? Voilà. Mhm. Yes. But you didn't take the case of NS. Yeah, default is just smoker. Very good. So, docteur, je vois que vous souffrez beaucoup avec le pipe. Il y a un shortcut, il y a un raccourci. C'est CTRL SHIFT et M. Oui, oui. CTRL SHIFT M, vous pouvez ajouter autant que vous voulez. Regardez. CTRL SHIFT M, je peux ajouter autant de pipe que je peux. Yeah. If you want to change it, you go to Tools, Global, and yeah, Tools, Global, and okay. If you click on Tools, you are going to see Global options down there. Have you clicked on the global option? Yes. So you are here. You will see something like this, isn't it? So you go to code, and now this one. Maybe yours is ticked. Untick it. Yeah, yours is ticked. Yeah. Is it ticked? If it is ticked, then untick it. Remove the... Ah, Seigneur. J'ai pas l'argent pour acheter. C'est moi qui ai cassé là. My friend is very... Am I the one who broke it? Oh, it is like this before. Ah, it's a house. Okay. C'est où? Vous avez antique? It's antique. Yeah. So now you can say, okay, go down. Yes, apply. And then okay. Now you control Shift M again. Shift control. No, control shift. But you're outside the chunk, eh? It's okay. You have to control shift. Yep. And when you write, you don't Alt minus, it automatically give you that assignment. Yes. Alt minus. I didn't know it before. Thank you, Blancha. Basha, let's agree that next time you teach art. Is that okay? Complete your masters very quickly. You know, like alt minus is even doing the assignment. I didn't know about it. I didn't know. Okay. That's why I like teaching. You learn every day. Alt minus. Yeah, alt minus. So yeah, guys, I've displayed the table of outcomes. Please try and clean it so that you can start the analytics. So you see that we have the word deceased written in like 2 different ways, recovered in 3 different ways, and ongoing in 2 different ways. So let me treat for deceased, and the rest you do it, okay? So I'm going to mutate, right? Outcome is equal to, so case when so I'm going to just use grepper, and then so that I can be able to ignore the case. So if I encounter disease like this in outcome, by ignoring cases, then the right spelling should be this one. So now, if I encounter disease, by ignoring the case means that it is going to detect both of these case, and then the unique value of them will be this one. All right. So if I run the code, something is wrong. What? Something is not right. No, it's case when, not case match. Case match does the same thing as case when, but they have different syntaxes. Okay. Yeah. So I've cleaned deceased. Please take some time to arrange the other ones. Sorry. From the start. All right. Allow me to pick this call. So tomorrow, Tassien and other colleagues will continue with this. It's all about generating summary statistics and visualizations using what we know and AI at the same time. Okay. And on Saturday, we start dashboarding. Next Saturday. How to build now a dashboard. Yes. How to shine. So all those codes will be in the backend, and then you can just click on drop downs. You see how things are changing. Bam, bam. Me, I just like the dashboarding part. The rest, wow, Papa, it's beautiful. Wow, wow, nice. This is AI. You are using AI too. Uh-huh. You know, AI, if you don't understand it, is going to mislead you. Hein? C'est fiable. Ça dépend de comment. Je vais vous montrer comment c'est fiable. ChatGPT parle beaucoup, mais je vous conseille Claude. Non, mais Claude, c'est... Non, mais heureusement que je n'ai même pas un ami qui s'appelle Claude. J'allais lui acheter une bière. Hein? Here where? In Rwanda?
Yes, it's accessible.
I told you yesterday I built an entire app. People are asking me even OTP. No, I built it from yesterday. You know, no, the day before yesterday night. I spent the night on it. In the morning I finished it, and then I shared the link. Now they are asking OTP. They are testing from Chad. It's Claude. If I tell you that I just check the code and I say, Claude, this one, please, can you do it that way? Claude will say, okay. And then at the end of the day, you have an app working perfectly accessible anywhere in the world. Huh? No, Claude is, I'm telling you. Huh?
How can I use it? That would work there.
If I tell you that this is developed in R. This is R. Everything is R. So I can log as an admin. And then it is waiting for the OTP. I just go to my email What is the email? OTP is somewhere here. It was. So OTP will be sent here. If I refresh.